Welcome to EMEA OCI Landing Zone series. I'm Paula Juarez, an OCI Landing Zone specialist, and my mission is to simplify how you onboard and operate workloads in Oracle Cloud Infrastructure. In this video, we will explore the OCI Sovereign Landing Zones. The OCI Sovereign Landing Zones is a conceptual and architecture framework designed to implement sovereign controls such as data residency, encryption, isolation, and many other features to simplify highly regulated OCI workloads deployments. Let's dive in and see how this framework helps regulated industries and governments meet strict national and regional requirements using OCI. Here are today's speakers, my colleague Peter and I, both part of the EMEA Landing Zone team, and we also have a special guest, Damian, with us today to break down the benefits of our OCI Sovereign Cloud. Let's start with the basics. What does a sovereign landing zone mean? An OCI landing zone is a secure cloud environment built with best practices to enable continuous onboarding of workloads and teams. It also helps ensure smooth HU operations, supporting scalability and long-term success. All of our OCI landing zone blueprints are aligned with the CIS benchmark, where CIS stands for the Center for Internet Security. The CIS benchmark are a set of best practices consisting of more than 60 recommendations across several categories, including network, security, and operations. This diagram represents one of our OCI landing zone blueprints, the 1OA landing zone. Many customers need to comply with local regulations or specific organizational policies. To address this, we have extended our OCI landing zone blueprints by incorporating additional configurations based on sovereign principles. So what exactly is a sovereign landing zone? It's a tailored OCI landing zone designed to meet specific data sovereignty, compliance, and security requirements as mandated by governments, regulations, or organizational policies. Around the world, organizations and governments are moving to the cloud, pursuing flexibility and cost savings. As the cloud keeps evolving, so do the rules and the regulations around it. With OCI Sovereign Landing Zones, we can meet security and data sovereignty requirements by building on a strong, reliable foundation. Our OCI Sovereign Landing Zones are built around 4 key principles. Location. Ensuring data is stored in the region where legal requirements mandate fully compliance with local data sovereignty laws. Isolation. Implementing isolation at multiple levels, such as network and environment, to keep data and systems securely separated. Access management. Defining who can access and process data with strict controls to prevent unauthorized cross-border access. And encryption. Protecting data at rest, in transit, and in use. Encryption is crucial for safeguarding sensitive information from unauthorized access. Some customers may focus on just one of these principles, while others must comply with all. Let's take a closer look at each principle in more detail. Let's start with the location principle. There is a growing customer demand for greater control over the physical location where data is stored. Let me start by explaining a few key concepts that are essential to understand how OCI delivers high availability, fault tolerance, and compliance with data residency requirements. Region. A region is a localized geographical area where OCI services are deployed. For example, in the public or commercial cloud, we have more than 100 regions, like London or Amsterdam. Each region is isolated from the others to provide data residency and disaster recovery options. Availability domain. An availability domain is a physical isolated data center within a region. Availability domains have independent power, cooling, and networking to reduce the risk of a simultaneous failure. The number of availability domains varies by region. For example, London has 3 availability domains, and Amsterdam currently has 1. While failures in an availability domain are rare, deploying your resources across multiple ADs helps ensure that a single point of failure doesn't impact your entire application. And the last, the fault domains. A fault domain is a logical grouping of hardware within an availability domain. Each availability domain is divided into 3 fault domains. These domains provide further isolation within an ID. In a hardware failure or maintenance event impact on one of the fault domains, the other two remain unaffected. This allows you to design your workloads for high availability event within a single ID. In addition, we have the concept of a tenancy. A tenancy is a logical boundary that represents an isolated environment for each customer. Each time we create a tenancy, it's assigned to a home region. Additionally, if needed, we can subscribe to extra regions to extend our services. OCI resources and services can be either global or regional based. It's important to understand this distinction in order to properly address concepts such as disaster recovery, redundancy, and high availability. We have global resources and local resources. Some resources in OCI are replicated by default across all subscribed regions, such as compartments and the default identity domain. Others, like secondary identity domains, can be optionally replicated across regions. IAM policies are also shared across regions, meaning they apply globally within the tenancy. We have also region-based resources like VCNs, events, alarms, or logs. In the slide, we have a single tenancy with London as the home region, and the tenancy is also subscribed to Amsterdam and Frankfurt. The IAM and security landing zone layers, which include compartments, group policies, and enable cloud guard and security zones, is deployed in the home region, London. Meanwhile, the monitoring and networking layers has to be deployed in each subscribed region, as they are region-based resources. Let's talk now about compartments. A tenancy in OCI consists of one or more compartments, which are used for the logical separation of resources. Compartments can be nested, allowing for a hierarchical organization. To manage permissions in OCI, we work with user groups, compartments, and policies. Groups are a collection of users with similar roles or responsibilities. Compartments organize cloud resources into isolated areas, and policies define what actions groups can perform on resources within a specific compartment, providing fine-grained access control. To control the location of data, OCI Sovereign Landing Zones include by design region-based policies and quotas, which can limit the use of services outside the intended region. Regions, availability domains, fault domains, tenants, and compartments form one cloud. In OCI, these called a realm. OCI realms are physical boundaries of a cloud offering, which can be operated by different teams and can possibly be part of different Oracle legal entities across the world. Your tenancy exists within a single realm and can only access regions that belong to that specific realm. Realms are physically isolated, meaning data cannot flow between them. Now, let's understand where the sovereign landing zone sits. And for that, let me invite Damian. Damian, the floor is yours.
Hi, everyone. Paola just explained us the sovereign landing zone principles, as well as the notion of realms. What I would like to speak about now is the notion of sovereignty compared to the notion of security, so that you understand perfectly where a sovereign landing zone sits, what it will help you with, and what it will not help you with, and which you should only do on your due diligence side when you pick up the cloud solution. So security is everything you do in terms of controls that you implement at the tenant level of the cloud that you use. A sovereign landing zone is exactly that. All the principles of the sovereign landing zone are going to be translated into controls enforced at tenant level. It does not change anything whatsoever to the hidden part of the iceberg, which is how is my cloud operating? Meaning not on your side of the shared responsibility model in terms of customers, but on the cloud service provider side of the shared responsibility model. This is why we have several realms, as Paula just explained. Depending on your sovereignty requirements, you want to pay close attention to where, who, and how the cloud is operated from. That's going to help you determine what kind of technological sovereignty, operational sovereignty, and data sovereignty you can achieve through the combination of the realm you're choosing and the sovereign landing zone controls you're implementing. On top of that, you need to remember that on your side of the shared responsibility model, if you choose a sovereign cloud, like for example, European Union sovereign cloud, or if you choose any other OCI cloud for that matter, you will have access, to about every cybersecurity category that you will need to implement best practice security. Not all of those tools are leveraged by the sovereign landing zone. So I invite you to make sure that you get to know each of those security tools in order to best implement your cybersecurity on top of the sovereign landing zone implementation, on top of your realm of choice in order to answer your sovereignty requirements.
Let us start with the second principle. Isolation is a fundamental component of the security and architecture model of any cloud infrastructure. OCI offers multiple layers of isolation to separate resources and safeguard workloads. In Oracle Cloud Infrastructure, we have multiple levels of physical isolation that ensure high availability, fault tolerance, and disaster recovery. These isolation layers include fault domains, availability domains, regions, and realms. We already have reviewed these concepts in the previous section in the location principle. In OCI, logical boundaries allow us to provide security isolation within the same physical infrastructure. Each OCI customer has a separate tenancy that is logically isolated. Resources are grouped into compartments for access control, and policies define which groups can access specific resources, enabling a logical isolation between teams, applications, or even environments. Our OCI landing zone blueprints incorporate best practices for logical isolation, including a well-structured compartment hierarchy and the use of identity domains to separate users and workloads. It also provides examples of groups and policies to support secure and organized access management. OCI delivers robust network isolation through three core layers: structured segmentation, access control, and private connectivity. At the foundation, virtual cloud networks, also called VCN, and subnets enable logical segmentation, while a hub and spoke network module centralize traffic flow to improve manageability and enhance the overall security. Access control is enforced using security lists and network security groups, which filter traffic at both the subnet and the instance levels. We also strongly recommend using firewalls to further isolate environments and business lines, establishing clear and secure boundaries. Finally, security zones can restrict potentially risk operations by enforcing baseline security policies, and additional features like private endpoints and service gateways ensure that traffic remains within OCI private network.
Our next principle for sovereign landing zone is access management. Access management plays a crucial role in ensuring segregation of duties and least privilege access control. The access management sovereign landing zone principle leverages three key OCI security services. IAM, short for Identity and Access Management, providing centralized control of authentication and authorization, as well as identity management. CloudGuard and Security Zone, a cloud security posture management service coupled with a policy enforcement service to define and enforce security policies and take corrective actions when issues are detected. Vulnerability Scanning Service, a readily available service to allow to scan all VMs and patch levels. Landing zone uses core OCI services like compartments, groups, and policies to implement a comprehensive approach to access management. Compartments are used by a policy boundary for permission enforcement, but also serve for logical separation of resources and can be nested. Groups are collections of users within the identity domain. Policies bind permissions to a group in a specific compartment. The Sovereign Landing Zone has been designed with SIS benchmarks as a guiding principle, and it's compliant with Level 1 SIS benchmarks out of the box. In the Sovereign Landing Zone, we include concepts such as segregation of duties and isolation of resources. These security controls allow customers to start a cloud journey with a set of best practices that can be deployed within a few minutes. Another tool on the list is CloudGuard. CloudGuard is a security posture management service that allows you to set up preemptive and remedial actions if security policies are violated. The Sovereign Landing Zone comes with a pre-configured CloudGuard for common rules and implements security zones to enforce parts of the SIS security controls. And lastly, Vulnerability Scanning Service gives teams the confidence that all instances on OCI have the latest security patches. Combined with Oracle CloudGuard, operations team gain a unified view of all instances to quickly remediate any open ports or patch unsafe packages discovered by the Vulnerability Scanning Service. In OCI, data is always encrypted by default. As a customer, you can further enhance your sovereignty level by adjusting how keys are managed to meet your requirements. Encryption is embedded across all OCI services with multiple options and a lot of flexibility to choose. When we talk about encryption, generally we think about three categories when data can be encrypted: data at rest, data in transit, data in use. Data at rest is data stored on a block volume or object storage and is ready for use by other services. Data in transit is when we get to the point where we need to utilize stored data and we need to transfer them to a specific service for processing. Data in use is the data on which computations are being performed and are loaded into memory for quick access by CPUs. OCI is the first CSP enabling data encryption at rest using Oracle Managed Encryption Keys by default across all storage services, including block, object, and file storage, as well as Oracle Platform Services. This automatic process ensures data encryption without requiring any user intervention. Oracle offers freedom of choice for key management. Our customers can choose either Oracle Managed Encryption Keys for customers who don't want to deal with a key management process. Oracle completely manages the encryption keys, simplifying security for all customers. Another option is Customer Managed Encryption Keys. For enhanced control and to meet stricter regulatory requirements, customers can entirely manage keys and their lifecycle and choose where keys are stored. We will discuss the key storage option in a second. All control plane data in transit is encrypted using Transport Layer Security TLS 1.2 or later, ensuring the data transmitted across the network is securely encrypted and never sent in plain text. Additionally, all data transmitted between availability domains and regions within OCI is protected using MACsec. Customers utilizing FastConnect for private connections between their on-premise data center and OCI can also enable MACsec encryption to secure this traffic. While Oracle manages in-transit encryption for control plane components, customers are responsible for implementing encryption for any in-transit data associated with their custom components or applications in their tenancy. OCI's confidential computing ensures the data remains encrypted during processing. It encrypts and isolates in-use data and the applications processing data at the hardware level using specialized AMD CPUs. A confidential instance is either a virtual instance or bare metal instance where both the data and the application processing the data are encrypted and isolated during the processing. It prevents unauthorized access or modification of either the data or the application during processing. The use of these specialized compute shapes can be enforced in our Sovereign Landing Zone framework. Oracle Managed Encryption, also called Virtual Vault, is a multi-tenant encryption service where your keys are stored in adjacent partitions shared with other customers. It is the default encryption service in Vault. Private Vault is a single-tenant encryption service that stores keys in private adjacent partition with isolated cores specifically for your tenancy. Both Vault options, Virtual Vault and Virtual Private Vault, allow you to create encryption keys stored either in software-protected or adjacent-protected mode. Software-protected keys use cryptographic operations, and key storage occurs on bare metal server with keys secured at rest using a root key from the HSM. Adjacent-protected keys use all cryptographic operations, and key storage is performed within the HSM itself. Another option is dedicated KMS, which provides a single-tenant adjacent partition as a service, offering a fully isolated environment for key storage and management. The main distinction from Private Vault is the level of control over the adjacent partitions. OCI also offers external KMS, which allow you to use your own third-party key management system to protect data in OCI services. You retain control over the keys and HSM outside of OCI. Master encryption keys, MAKs, are always stored outside of OCI. From a sovereign point of view, it's recommended to have custom-managed keys stored on external key storage. In order not to incur any cost, OCI Sovereign Landing Zone Blueprint uses the Virtual Vault, customer-managed encryption software keys option, but we do recommend to consider options with adjacent storage or external key storage based on the regulation requirements. So how can you get started today? To start with Sovereign Landing Zone, first deploy one of our standard operating entities models. The Sovereign Landing Zone is then deployed on top of the already existing landing zone to implement specific sovereignty requirements. The add-on is fully compatible with either one-OE, multi-OE, or multi-tenancy landing zones. Today we've learned about Sovereign Landing Zones and its key principles. The Sovereign Landing Zone provides a secure solution for organizations deploying workloads in the cloud. By following mentioned key principles, customers can ensure their cloud infrastructure meets local regulations while also benefiting from improved security, simplified management, and cost savings. To learn more about OCI Sovereign Landing Zone, visit our GitHub repository for detailed documentation, examples, and code snippets. Thanks for watching, and see you next time.